Good morning. To continue our discussion, the topic that we are going to discuss is nonparametric statistics. Nonparametric statistics, these are used because conditions are not stringent or controlled. There is a smaller sample size, nominal and ordinal data are used. So the distribution is not normal. So the first nonparametric test is the chi-square test. So this is a test of difference between the observed and expected frequencies. The chi-square is considered a unique test due to its three functions, which are as follows: the test of goodness of fit, the test of homogeneity, the test of independence. For the chi-square test of goodness of fit, this is a test of difference between the observed frequencies and the expected frequencies. So the formula that we will be using is chi-square is equal to the summation of the observed minus expected squared divided by expected. So, for our example, in the theory of Mendel regarding crossing of peas, it is in the ratio of 3:3:3:1, meaning 9 parts are smooth yellow, 3 parts are wrinkled yellow, 3 parts are smooth green, 1 part is wrinkled green. The researcher conducted an experiment and the result was that out of 560 peas, 310 were smooth yellow, 100 were wrinkled yellow, 110 were smooth green, and 40 were wrinkled green. Question: is there a significant difference between the observed and the expected frequencies? So we will be using chi-square test at 0.05 level of significance. So, for our problem statement, is there a significant difference between the observed or the actual experiment and the expected or Curie frequencies? So for our hypothesis, there is no significant difference between the observed and the expected frequencies. Here, it can also be expressed as the null hypothesis is observed is equal to the expected. So for the alternative hypothesis, there is a significant difference between the observed and the expected frequencies. Our alternative hypothesis, or HA, can also be expressed as observed frequencies is not equal to our expected frequencies. And then, for the level of significance, we have there alpha at 0.05. For the degrees of freedom, we have H minus 1. We have here, our H is the number of groups. In our problem, we are given smooth yellow, wrinkled yellow, we have smooth green, and wrinkled green. So all in all, we have 4. There's 4 minus 1, we have 3. Okay? So here, our chi-square at 0.05, based on our table, is 7.815. For the statistical treatment, we will be using chi-square goodness of fit test. So in our computation, we have there, again, for smooth yellow, we have smooth yellow, okay, wrinkled yellow, smooth green, and wrinkled green. Okay, so given we have our observed frequencies, we have 310, okay, smooth yellow, 100 wrinkled yellow, 110 smooth green, and 40 wrinkled green. So for our expected frequencies, we are given the ratio. That is 9:3:3:1. Okay? So this is our ratio. To get our expected frequencies, we have there the 560 piece. We add our ratio 9 plus 3 plus 3 plus 1. That is 16. Okay. So we have here 560 divided by 16. It gives us 35. So meaning we have 35 per part. 35 piece per part. So for the smooth yellow, we have 9 times 35. That is 315. Then for wrinkled yellow, we have 35 times 3. That is 105. Then 105 And then we have 35. So, next is get the difference between the observed and the expected frequencies. We have here 310 minus 315, that is negative 5. 100 minus 105, that is negative 5. 110 minus 105 is 5. 40 minus 35 is 5. Okay? Then, for the chi-square, that is equal to the summation of the observed minus expected squared over expected. Using this formula, we have there, the difference is negative 5 squared divided by the expected frequency for smooth yellow is, we have 315. Plus, the next one is for the wrinkled yellow, we have negative 5 squared divided by 105. And then, for the smooth green, we have 5 squared divided by 105. And then plus, we have for the wrinkled green, that is also 5 squared divided by 35. Okay? So for our computed value of chi-square, we have there, we have negative 5 squared over 315 plus negative 5 squared over negative 5 squared over 105 plus 5 squared over 105 plus 5 squared over 35. Okay? So our computed value of chi-square is 1.26. Okay? So, for our decision rule, again, it's if the chi-square computed value is greater than the chi-square tabular value or critical value, we reject the null hypothesis. Okay? So, for our conclusion, okay, so here, since the chi-square computed value of 1.26 is less than the chi-square at 0.05, which is equal to 7.815, we fail to reject the null hypothesis. There is no significant difference between the observed and expected frequencies. Okay? So for our next example, a certain machine is supposed to mix peanuts, hazelnuts, cashews, and pecans in the ratio of 4:3:2:1. So a can containing 500 of these mixed nuts was found to have 270 peanuts, 110 hazelnuts, 80 cashews, and 40 pecans. At 0.05 level of significance, test the hypothesis that the machine is mixing the nuts in the ratio of, or at the ratio of 4:3:2:1. So for this one, our problem statement is there a significant difference? Is there a significant difference between the observed and expected frequencies or values? Okay? So, here, our hypothesis is, the null hypothesis is our observed frequencies or observed values is equal to our expected values, or there is no significant difference between the observed values and the expected values. And of course, HA is the contradiction of the null hypothesis that observed is not equal to the expected values. Okay? So, next is our level of significance. We will be using, again, alpha at 0.05. Okay? So, for the degrees of freedom, since we have, again, 4, okay, we have peanuts, hazelnuts, cashews, and pecans. That would be 4 minus 1, that is 3. And chi-square at 0.05, that is equal to 7.815, according to the table. So, for the statistical treatment that we are going to use, or statistics, we'll be using chi-square test of goodness of fit. Okay? So, for the computation, we have there peanuts, hazelnuts, cashews, and pecans. We have peanuts, then hazelnuts, then cashews, and then pecans. So, for the observed values, we have there 270, then 110, 80, and then for pecans, we have for cashews, we have 80, for pecans, we have 40. Okay, then this is our observed. For our expected values, again, we are given the ratio of 4, 3, 2, and 1. So we have there 4, 3, 2, and 1. This is our ratio. So we have here 4 plus 3, 7, plus 2, 9, plus 1 is 10. So to get our expected values, okay, so we have there, we need to add our observed frequencies. We have there 210 plus 110 plus 80 plus 40. We have there 440. Okay? Oh, wait. It's not 2, it's 270. It's 270. We have there 270 plus 110 plus 80 plus 40 is equal to 500. This is 500, not 440. 500. So 500 divided by 10, we have 50 per part. So for the expected value, we have there 50 times 4, we have 200. We have 50 times 3, we have 150. Then 50 times 2, we have 100. 50 times 1 is 50. Okay? So again, we get the difference between the observed minus the expected, or observed and between the difference between observed and the expected. We have there 270 minus 200 is 70. We have 110 minus 150 is negative 40. We have 80 minus 100 is negative 20. And 40 minus 50 is negative 10. Okay? So for the observed minus expected squared, we have there 70 squared, we have 49. 4,900. We have 40, negative 40 squared, that is 1,600. And then we have negative 20 squared, that is 400. And we have 10 squared, we have 100. So, using the formula, okay, chi-square is equal to the summation of the observed minus expected square divided by expected. We have there 4,900 divided by our expected is 200, plus next is we have 1,600 divided by 150, plus we have 400, okay? 400 squared divided by 100 plus, the last one is 100. This is not squared, okay? 100 over 50. So for our chi-square, we have there 4,900 over 200 plus 1,600 over 150 plus 400 over 100 plus 100 over 50. So that is equal to 41.17. Okay? Again, let us check. We have there 270 minus, okay, first 270 minus 200 squared over our expected value 200 plus we have 110 minus 150 squared over 150 plus we have 80 minus 100 squared over 100 over 100 plus we have 40 minus 50 squared over 50. Okay? Okay, so it's right. 41.17. So for the decision rule, okay, so we have here, if the chi-square computed value is greater than chi-square at 0.05, we reject the null hypothesis. So for our conclusion, we have, since chi-square computed value is equal to 41.17, okay, it's greater than our chi-square at 0.05, which is 7.815, we reject our null hypothesis. There is a significant difference between the observed and the expected values. Okay? Then, next is the chi-square test of homogeneity. So for this one, this is concerned with two or more samples with only one criterion variable. So this test is used to determine if two or more populations are homogeneous. Its data distributions are similar with respect to a particular criterion variable, and the formula is chi-square is equal to n times AD minus BC squared divided by KLMN. So n times AD minus BC squared over KLMN. So for our example, evaluate the attitude of Lakas and Laban parties on the issue of peace and order in Mindanao. So to carry out the study, a separate random sample of members of each party is drawn from the nationwide population of Lakas and Laban, and each individual in both samples responds to the scale. Scores are then classified into favorable or unfavorable categories. The following frequencies are obtained. So we have therefore Lakas, we have 65 for favorable and 35 for unfavorable for a total of 100. For Laban, we have 50 for favorable and 50 for unfavorable, which gives us 100 for the total. For our favorable, the total is 115, and for the unfavorable, we have 85. So in here, in our table, this is your A, B, C, D, and then your K, L, M, N, and then this is your capital letter N. Okay? So, we may proceed with the computation. So, here we have our chi-square is equal to N times AD minus BC squared over KLMN. Okay? So, our N is 200 times our AD, that is 65 times 50. Okay? Minus our BC, we have 35 times 50. Squared divided by our KLMN, that is 100 times 100 times 115 times 85. Okay, so for our computed value of chi-square, we have there 200 times 65 times 50 minus 35 times 50. Okay, we have there 35 times 50. Okay, squared over KLMN, we have 100 times 100 times 115 times 85. Okay, so our computed value is 4.60. Okay, 4.60. So, for the tabular value, okay, so let us check. For the level of significance, okay, so here, the level of significance, our N is, okay, for the level of significance, let us test this at significance. Let us test this at alpha is 0.05. From the chi-square distribution table, for our degrees of freedom, we have the columns minus 1 times row minus 1. That is 2 minus 1 times 2 minus 1, we have 1. Okay, so chi-square at 0.05, we have 1. At 0.05, we have there 3.84. Okay, 3.84. So, our statistical treatment, we have there chi-square test of homogeneity. Okay, so for the computation, we have already done that, and our computed value of chi-square is equal to 4.6. Okay, so again, for the decision rule, we have there if the chi-square computed value is greater than chi-square at 0.05, or the tabular value of chi-square, we reject HO. So for our conclusion, since chi-square computed value that is equal to 4.6 is greater than the chi-square at 0.05 that is equal to 3.84, we reject the null hypothesis. Okay? We reject the null hypothesis.